Hi, I'm Chris. I'm going to give you a taster today of what it's like to study A-level maths at HNC. So what I'm going to do for you is show you some techniques we use in A-level maths to sketch graphs. So I'm going to sketch this graph of the function y equals x cubed minus x squared plus 2. Hopefully some of the techniques I'm going to show you here are familiar to you, and some of them I'm sure will be new. The idea is to give you a flavour of how A-level maths extends what you've learned at GCSE. So we're going to try and sketch the graph on an xy axis. So first of all, I can very easily work out where this crosses the y-axis, because it's going to be 2, because the y-axis is where x equals 0. So that means I know it's going to go through that point there, right? Because if x equals 0, y must equal 2. So I've got 1 point. I also know roughly what it's going to look like, because this is a cubic, and we know what cubics look like. They look something like this, or like this, or maybe like this, all right? And it is a positive cubic because the x cubed has got a positive coefficient of 1. So that means it's got to be one of these two shapes, okay? One of those two shapes. So I know roughly that I'm looking for something like that, but I need to know the details. And first of all, I want to know, where does it cross the axis? So does it do something like this? Could do that. Or does it do something like this? Either of those are possibilities, and there are many more. So let me rub out those. So the first technique I'm going to use is something called the factor theorem. So this is telling us if we have a function, if I write the function x cubed minus x squared plus 2, I can factorise it. I can find a factor by looking for x values where it gives a 0 value. So I'm essentially trying to find where it crosses the x-axis. So all I'm going to do is try some numbers in the function and see where I get 0. So first I'm going to try f equals 1. 1 cubed minus 1 squared plus 2 is 1 minus 1 plus 2 equals 2. So that is definitely not 0. Let's try 2. And one thing we teach you at A-level is how to do things like this quickly on your calculator. So you probably have one on your calculator now, but you might not be aware of it. A thing called a table function that will put lots of numbers into an equation for you to do this nice and quickly. I'm going to get 8 minus 4 plus 2 equals 6. So this isn't looking very promising. That number seems to be getting bigger, and I'm looking for something that gives me 0. So I'm going to try some negative numbers. Minus 1 cubed gives me minus 1. Minus 1 squared gives me 1. Plus 2 equals 0. So bingo, I've got it, right? It's 0. That's telling me at x equals minus 1, it crosses the axis. So I know it goes through that point there as well. Now, the factor theorem tells me that if f of minus 1 equals 0, then that means that x plus 1 is a factor of the function. So I can write fx equals x plus 1 and then some other factor. So it's helping me to factorise this cubic equation. So now I need to work out what goes in these brackets. Now there's various different methods for doing this. One you'll learn at A-level maths is called polynomial division. So essentially you can take this and you can divide it by x plus 1 using long division, right? I can do it quicker than that just by trying to think about what I need to put in here to make this come out. So I've got to have an x cubed when I multiply out this bracket, so I'm going to have an x squared in there, right? Otherwise there's no way I'm getting an x cubed. And there's no coefficient on that x cubed, so x times x squared is going to give me x cubed. So that's fine. Then I also need to get a 2 out at the end. So that means I've got to have a plus 2 at the end, because I'm going to do that times that, and that's the only constant term when I multiply it out. So 1 times 2 gives me 2. So then the only question is what goes in front of the x in the middle, right? So I've called that p. And then if we just have a look at what's going to happen when we multiply this out, we can try and reason what p must be. So when I multiply it out, that is going to multiply with that term to give me px. And this x is going to multiply with that 2 to give me 2x. And those are the only bits when I multiply it out that will give me an x. That's got to come out as this minus, that's got to come out as 0 because there's no x term. So that's got to be 0. And that tells me that p has got to be minus 2, right? So I can write that in there. So that's factorised it. I just want to check that this gives me minus x squared. So if I do the same thing and I look at pairs of terms that give me x squared, I've got x paired with that, okay? That's going to give me minus 2x squared. And I've got 1 paired with x squared, and that gives me x squared, and that comes to minus x squared, which is exactly what I've got there. Okay, so I have successfully factorised that function, all right? So I know that it passes through that point there, but maybe I can factorise this function as well. Maybe I can factorise this function and find more points where it's 0. So let's call that gx and then try to factorise it. Now, this is a quadratic, and you know how to factorise quadratics. If you try the techniques you've used at school to factorise quadratics, you're going to find they don't work on this. So really, to factorise it, I want to try and find where it's equal to 0. And you've probably already studied a way of doing that, which is completing the square, which is a really important technique at A level. So to complete the square, first of all, I write it like this, and when I multiply this out, it's going to give me x squared, and it's going to give me the minus 2x, but it's also going to give me a 1 that I don't need. So I need to subtract that off. And then this gives me x minus 1 squared, and if I calculate that and move it to the other side of the equation, I get minus 1. Now you might be able to see that there's a problem here, which is to solve this equation and get x, I'd have to square root it. And I can't square root minus 1, right? So I'm stuck. That means I can't factorise it, all right? Another way of doing this will be using the quadratic formula, which you also know from GCSE, and the b squared minus 4ac bit in the quadratic formula. That's going to give you a minus number, and that tells you that you can't factorise it using what we call real numbers. So I can't factorise that, and that means it doesn't go through the x-axis again. That is the only place it goes through the x-axis. So what I know now is it's going to look, it could look like this, something like that, or maybe it's going to look like this, like that, or maybe it's going to look like this. Okay, all those things are possibilities at the moment because all I know is it's a cubic and it goes through those 2 points. So, how are we going to work that out? And what we're going to do is use calculus. So this is a new thing at A-level maths. You might come across it if you do further maths at GCSE level. And the idea of calculus is to be able to generate a function that tells us the gradient of this, right? So if I've got a cubic, if I just sketch any old cubic, what I really want to know to understand the shape of it is where are these points here, right? Which we call the turning points or the stationary points. And what is interesting about those points is that the gradient is 0, right? The gradient in this section is positive, the curve is going up. The gradient in that section is negative because it's going down, and the gradient in that section is positive. And the point where it switches over between negative and positive are those points there. The gradient there is 0. If I drew a tangent to the curve, it would be flat, and the gradient is 0. So what I do is I generate what we call the gradient function or the derivative of fx using a process called differentiation. And we write that like this. F prime x is how we say it. So this is going to be the gradient function of fx. And there's a nice little process for doing it with polynomials like this. So what we do, we take the index of the polynomial and we multiply by it. So I take that 3 and I put it in front, and then I lower the value of the index by 1. So I get 3x squared like that. Then I'm going to do the same for this one. I'm going to multiply by that 2, and then I'm going to lower it by 1. And x to the power 1. Of course, x to the power 1 is just x, so we don't bother with the 1. And then to do the same with the 2, we could imagine that that is x to the power 0. And do the same rule, which means I'm going to multiply by 0. So that's just going to wipe it out. So the last term just disappears. So that is our gradient function. And what I want to know is, where's that 0? So I need this to equal 0. So now I need to solve that. That's another quadratic. Take out a factor of x. And there are then two solutions to that quadratic, which are x equals 0. This could be 0. And x equals 2/3 will give me that. So those are going to be where my turning points are. So there's going to be a turning point at x equals 0 and a turning point at x equals 2/3. Then I need the coordinates of those turning points. So I'm going to take these values and put them back into this equation. So x equals 0, that's easy. If I put x equals 0 in, I just get 2. So that means this is going to be a turning point. So the curve is going to be flat at that point there. If I put x equals 2/3 in, it's a little bit stickier. And then I need to multiply out those fractions, get myself a common denominator, and I end up with this. It comes out as 50 over 27. Now 50 over 27 is just slightly smaller than 2. So what that's telling us is there's a turning point there. So at that point there, x equals 2/3, y equals 50 over 27. There's also a turning point. And now I can finish the sketch. I know it's going to come up like this. It's got to go flat through there, so it must go flat there, and then must come down, and then must go flat there, and then go up again. And there's my sketch of the graph with my accurate places where it crosses the axis, and my coordinates of my point here where it changes direction and then increases. So there's a whole barrier of things there that you come across in A-level maths. Some will be familiar, some will be new. Calculus is the big new one. You take these basic ideas of gradient functions and you go much further with it. It's really, really interesting. If you enjoy maths GCSE, you're going to love A-level maths. So I really recommend taking A-level maths and coming here to HNC to study it. Thank you.